All right, well, let's get down to brass tacks. We're going to be looking at the power rule, and it's this rule here if you're doing IB, and this rule here if you're doing NCEA. So this is going to be doing most of the heavy lifting for polynomials when you need to differentiate something. So these two statements are equivalent. They're written slightly differently, but they are the same. The nx n minus 1 bit is the same for both. So let's look at it. Let's look at the notation first for the IB. So it says that when fx is in the form x to the power of n, when we come to differentiate it, of course that's going to be f dash of x, and that's going to be equal to n x, and we take 1 away from whatever number is in the power. So the n here comes out the front, a little bit like logarithms, and then it loses 1. So we can rewrite that as well. Well, we need to differentiate with respect to x, that's what that means, and it's in the form x of n. When we differentiate it, it's n, the n comes out the front, the x stays there, and the indice loses a power. Exactly the same formula, just written slightly differently. Okay, let's look at some examples. Let's say that f of x is 4x cubed. It's a really bad x. 4x cubed, and we want to differentiate it, so we want to find f dash of x. Well, we know that the n is 3, and then there is this 4 out the front. Well, it doesn't matter. It's just going to be 3 times that 4. So f dash of x is going to be 3 times 4 x, and then the 3 will lose 1 power, exactly as it is up here. So when we do all of that in one go, 3 times 4 is 12x squared. And we do each term separately. So if we have something in this form, y equals 3x to the power of 2 plus 5x, and we want to differentiate that, so we want to find dy dx, differentiate y with respect to x. It's going to be, the 2 is going to come out the front, and then it's going to lose 1, so that's just going to stay there. Now, what's going to happen when we have the 5x? Well, what number is up here to start with? It's a 1 up there to start with. So it's going to be 1 times 5x, and 1 minus 1 is 0. Now, x to the power of 0 is 1. So therefore, this is cancelled out. There's no point in saying 1 times 5 times 1. That's just going to be 5. So the end answer here is going to be 2 times 3, which is 6. X to the power of 1. We don't need to write the 1. And then it's just going to be plus 5. That x is going to disappear. Okay, so sort of a rule of thumb is some number x, if there's nothing up there, when we differentiate it, it's just going to become a, that number, any number. All right, works for negative number as well. So if we have f of x is negative 3 x to the power of 4 plus 2x cubed plus 3x, say, it's going to be exactly the same thing. 4 times negative 3, x to the power of 4 minus 1 is 3. That's that term done. Plus 2 times 3 is 6x. 3 minus 1 is 2. And then the x is by itself, so that it's just going to become a 3. If you want 3x to the power of 0. And then when we come to rewrite that, so 4 times negative 3 is negative 12 x cubed plus 6x squared plus 3 times 1 is 3. Remembering that x to the power of 0 is 1. That will be that done. Okay. What happens if we have a constant term? So say we have 4x squared plus 8x plus 5. And we want to differentiate that. Okay, the 2 is going to come out the front, so 2 times 4 is 8. The x is going to become a 1. We don't need to write that 1. The 8x is going to become 8. And what happens to this 5? Let's work it out. So at the moment, it's 5x to the power of 0, 5 times 1. Well, when we come to differentiate that, it's going to be 0 times 5x to the power of negative 1. It looks complicated, but it's times 0, so the whole thing goes. This constant term literally annihilates. Annihilates is, I think it's a Latin term, it means going to nothing. It disappears. So generally when we have polynomials, when we differentiate it, it becomes a more simple formula, a more simple equation. Okay, let's do another one. If f dash of x is 5x to the power of 5 minus 4x cubed plus 2x plus 1,000. Okay. Remember, we're looking at a change with respect to a change in x. There's no x term here for the constant. Therefore, it's not going to change. 1,000 is going to be 1,000. It's going to be 1,000 by virtue of being constant. So let's differentiate it. F dash of x is going to be 5 times 5, which is 25. And then we lose one up here. It becomes 4. And then we're going to have 3 times negative 4, which is negative 12 x, and then the 3 will lose 1. That's going to be to the power of 2. There's a 1 here. The 1 times 2 is 2, and that x disappears. And the constant term here, there's no x in it. So therefore any change in x is not going to be affected by that, so that goes. And that's going to be our answer. All right. One other thing. And it's just it's kind of a little tip. If we have something like y equals 4x squared over 3, how would we differentiate that? Well, we could do it a couple of different ways. If someone sent me a text message, we could move this 2 out the front here. So it's going to be 2 times 4x over 3, which is going to be 8x over 3. We could do it like that. Or we could rewrite this one to be 4 over 3 x squared. And then when we come to differentiate that, it's going to be exactly the same. It's going to be 8 over 3 x to the power of 1 when we come to differentiate it. So that's the y, and that's the difference of y with respect to a change in x. Okay, that's a little introduction to the power rule. It's really, really important. So we'll be doing quite a bit of